So we're going to do lesson 31, which some of it is review. And so that is a great thing to have. It's a review. We're going to start with oxidation states, how to assign oxidation numbers. So this whole lesson is about balancing redox reactions, which is a really important thing to be able to do because these are going to be questions that'll be kind of easy for me to write for your exam, because I can give you the the equation with blanks and ask you to fill in the stoichiometric factors, and you're going to have to be able to jot down on paper what the how to do this method that I'm going to show you here, and then be able to fill out the numbers. Okay, so one of the things we have to review is assigning oxidation numbers. We also call them oxidation states. Okay, so we kind of go back and forth. Okay, so these are the following rules that we discussed last semester. The important thing here is that the rules that are at the top take precedence over the ones that follow behind. So number 1 is the most important, number 6 is the least important. So the first thing is that the sum of all the oxidation states for the individual species in the compound must equal the overall charge on the species. So CO2 is a neutral molecule. Its overall charge is 0. Phosphate, on the other hand, is not a neutral molecule. It is a polyatomic ion with an overall charge of 3 minus. Okay, so that's what this rule right here says it pertains to. In free elements, in the uncombined state, so in their elemental state, so that's another way of thinking about it, in their elemental state, each atom has an oxidation number of 0. So aluminum, sodium, oxygen, which is a diatomic, chlorine, which is a diatomic, and even sulfur exists as a, it's kind of neat, it exists in a 8-membered ring, something like that. And so that's how sulfur exists in its elemental state. So they all have an oxidation state of 0, meaning they're neutral, they have no overall charge. For ions composed of only one atom, like monoatomic ions, the oxidation number is equal to the charge on the ion. So oxide is a monoatomic ion. Its overall charge is 2 minus. Okay. In compounds, so these are the rules start to get important. In compounds where fluorine is present, it always has an oxidation number of -1. Okay, so that's the first important rule where it comes to assigning an individual ion. Fluorine always gets to be a -1. In compounds, oxygen usually has an oxidation number of 2 minus. So you see this says always, but oxygen is usually. The major exception to this is peroxides, like H2O2, where the oxidation number is now going to be -1, because hydrogen is +1 +1. Both oxygens have a -1 charge, which makes hydrogen peroxide neutral overall. In compounds where hydrogen is present, it is also usually +1, except when it's bonded to metals in a binary compound. So these are our usually things like lithium hydride, sodium hydride, calcium hydride. They're strongly reducing agents, and so in that case, the oxidation state of hydrogen actually becomes a negative number, because the lithium and the sodium and the calcium are going to keep their positive charges, which makes the hydrogen the anion in this case. Okay, so these are really important review rules for you guys to remember. Now, balancing redox equations. This is kind of the new thing, but it's only going to be new in one way, because in Chem 1311 we talked about redox equations, and we did half reactions. So say you had copper plus 2 electrons forms copper solid, neutral. And then say that reaction occurs with aluminum losing 3 electrons. And we want to know, these are the net ionic, the half reactions. And we want to know what the overall reaction is going to be. Well, we remember when we added them together, we said the number of electrons had to cancel out. So we multiplied one equation by 3 and the other one by 2. And that gives us 3 times as much in our copper half reaction and 2 times as much in our aluminum reaction. But now when we get ready to add up the equation, our 6 electrons cancel out, leaving us with a not only mass balance equation, but it is going to be balanced as far as overall charges go. Okay, so we kind of did something similar to that last semester. Okay, so how this is going to work is step 1, we're going to write the unbalanced equation for the reaction in the ionic form. Okay, we're going to separate the equation into 2 half reactions. That's what these are right here. We're going to balance each half reaction for the number and types of atoms and charges, so that's where we multiplied by 3 and 2. If needed, we're going to add water if there are unbalanced oxygens, and we're going to add hydrogens to balance out any hydrogens. If the oxidation and reduction half reactions contain different number of electrons, we're going to multiply one or both of the reactions to equalize the number of electrons. That's what we did up here. They had to be 6 electrons on the left and 6 electrons on the right. Then we get to add the 2 half reactions together and balance the final equation by inspection. So this is where we're just basically going to double check ourselves. The electrons on both sides must cancel, but we need to make sure that other things don't cancel. So we're going to check, are there other things that cancel out? Verify that the equation contains the same type and numbers of atoms and the same charges overall on both sides. So we're looking for mass balance and charge balanced. Okay. If the redox reaction is in an acidic medium, no more steps are required. We can stop. If the reaction is basic, where in a basic medium, OH ions must be added to both sides in an amount equal to the H plus ions. Because remember, if we have an acidic solution, these are protons. In a basic solution, we don't have protons. We're going to have hydroxide ions. We learned that back in chapter 14. So we're going to add the OHs to replace the hydrogens. And then where the H pluses and the OHs appear on the same sides, they're going to combine to form water. Okay? So that sounds incredibly difficult. And I want to break this video up into 2 separate ones. So I'm going to give you guys a chance. I want you to digest the rules, maybe make sure you have them out on a piece of paper. And then I would recommend that you probably want a spare sheet of paper of some sort when we're doing these problems, because I want you to kind of follow along with the steps that I'm going to show you. And I think you might need more paper than what's here. Okay? All right, so we'll do the next part 2 video coming up.